Well, good morning. How's everybody? Hope everybody's good. This is Hubby with Just About Anything Garage, and we're back onto the C30 project. But as you can tell, we're not in the shop, we're in the office right now. And the reason we're in the office is we're at the point where we need to start to do the design and get an actual rollback body onto this thing. To do that, we need some information. And what that means, we have to run through some math. And you guys are going to get a math course. I'm going to run you through the math that it takes to figure out what we need to do here, okay? So sit tight and hang on, because we're going to jump right into this thing. I'm going to get you all set up, and we'll fire up from there, all right? See you in just 1 second. All right, so we're all set up here, and I've got it all drawn out for you, and I'm going to run through it, all right? So I'm not going to make you go through excruciating portions of it, but we do need to do some geometry, trigonometry, and some regular math. So, you told your math teacher you're never going to use it, but I'm going to show you where you are going to use it. But let's start here a little bit, and I hope you can see it because I'm behind the camera, and I'm trying to get you lined up here a little bit with some factoids with respect to what we have. So here's a couple of things that we just need to know, okay? We've measured the distance. We know that from the back of our cab to the end of the frame rails, we have 126 inches. That's 10 feet, 6 inches, right? We know that we're going to do 66 inches of overhang from the pivot point of where we're going to have our sliders mounted, overhanging to the edge. So that's 5 feet, 8 inches there. We've already selected our hydraulic cylinders, and they have a 42-inch stroke, so we know that it's going to extend the bed 42 inches, right? So if we go ahead and we add the 66 inches with the 42 inches, we get 108 inches. Now we're going to go, I'll tell you why that's important in a minute here, but just run with the factoids for a second. Okay, that then gives us, because we're going to have a 16-foot bed, a total length of 192 inches. Okay, so the remainder of the bed after that 108 inches is 84 inches. Now where does that all line up? Well, let me show you with the factoids in here. Okay, so here's the picture of the truck assembly. We got the ground level here, we got the tires, we got the frame rails above the tires. This portion here is the deck moving down. So here's what we've done. Let's tilt this deck flat again, and let's go ahead and extend the cylinder. So it's up against this end here towards the cab. We're going to extend the cylinders. It's going to move the deck out 42 inches. So we already had 66 inches, right? So the 42 extension gives us that 108. And then when we tip the deck, it's going to come down, it's going to hit the ground, and it's going to form a triangle, right? So what's the triangle going to be? Well, it's going to be from the pivot point to the ground, out to where the edge of the ramp meets, and then back up to the pivot point. So we know that that's 108 inches, right? So that's basically what? 8 feet, 6 inches, something like that? Of ramp that's going to be extended out there. We're going to figure that out here in just a second. So what it does is it gives us this triangle here, and actually gives us two triangles. The base triangle for the ramp that's coming from the pivot point to the ground, and then the rest of the ramp going up to where the lift arms connect and support it. So we got to figure out a couple things, okay? Fortunately, we have this guy named Pythagoras who gave us a formula that allows us to figure out some distances. Okay? We can measure, actually, from the pivot point to the ground for the C30. We know what that is. It's 30.5 inches. So that's the A side of this triangle, right? Okay? We know what the C side of the triangle is. We just figured that out. That's 108 inches. It's the ramp that goes there. So what is the actual distance from the pivot point out to where the ramp hits? Well, again, Pythagoras gave us the answer, right? Using the Pythagorean theorem over here. Let me turn you and mark it down a little bit. We know that a squared plus b squared equals c squared. So if you do the math and you want to figure out b equals the square root of c squared minus a squared. Plug the numbers in, right? The 30.5 inches, the 108 inches, and you do your calculations, and you're going to find out that your B length is 103.6 inches or 8 feet 7 inches. So from the pivot point out to where it hits the ground is going to be 8 feet 7 inches away. So you're going to form a ramp. That rollback ramp is going to be at 8 feet 7 inches out and up to the back of the pivot point. That's your initial ramp. Okay? So we know how much that we're going to climb to get up to the back of the rails. Now what we want to figure out is we want to figure out what the slope of this is, right? Because we don't want it too great a slope to make it hard to wind up. We don't want it too shallow a slope because it'll put excessive amount out there and we could sag on the ramp part. We don't want to do that. So what is slope? Slope was simply the ratio of how much it rises for how much it runs at every given point. So it's rise over run. So we can figure the slope out for this because we have these two measurements at 30.5 divided by 103.6, which is 2.2944 inches per inch. So for every inch of rise, for every inch of run, you get 0.2944 inches of rise. That's your ratio on that, okay? Now, as it works out, we can figure out what the angle of that incline is. Because if you do the math, and I'm not going to run you through that part of it, you'll find out that it's the inverse tangent or the arc tangent of the slope. Which in this case, if you do an arc tangent of the slope, it's 16.404 degrees, okay? So we know that this ramp is going to go up just a little over 16 degrees. It's going to be 108 inches on the ramp, but it's going to span 8 feet 7 inches and climb 30.5 inches to get up to the pivot point on the back of the rails. All right, so now let's swing and let's move down here and let's look at the other triangle because that gives us another important piece of information is how long do our lift arms have to be and where do we need to position them for that. We know that the ramp that goes to the ground to the pivot point is 108 inches. We know that the total length of our deck is going to be 192 inches or 16 feet. So we know that we have 84 inches on this triangle, the C leg here, left over, okay? Since we know that, we can figure some information out. Now, one of the things that we can figure out is shown right here, okay? We know the slope. We know how much it rises over the run. So what that's basically telling us is for however much run you have, you can calculate what that length is by multiplying the length, the point of length here by what the slope is to give you the total height of the ankle. So we know that we have 84 inches out to here, right? That's the total length of the run, the physical length of the hypotenuse that we're going to have. So if we go ahead and we take 84, we multiply it by the slope over here, we're going to get 24.7 inches. So we know that from a level equal to the pivot point up to the top of the ramp is 24.7 inches. So we got our lift angle arm. A lift arm length, sorry about that. But it gives us a little bit of a problem, okay? Can you see what that problem is? I'll give you a second. All right, you got it in your mind? Here's what our problem is. Let's take the lift arms off for a second and let's tilt that deck back up level, okay? It's going to hang out 108 inches and it's going to have 84 inches sitting up on the rail. But we also know that we have a stroke length of 42, which makes up 104 of this. So when we go to push the deck back and withdraw the hydraulics to pull it back, it's going to move 42 inches back. But we have a problem. What? Our lift arms are only 24.7 inches long. So when they go to sweep down, they're only going to allow it to go back 24.7 and then stop because that's the length of the arm. So we got a problem. We have to fix that problem. We need 42 inches of travel in that deck that's running through an arc, okay? So how do we get that? Well, that's actually pretty easy. If you take 42 inches and you subtract 24.7 inches, you get 17.3 inches. So we can drop that pivot point down 17.3 inches and we'll have our 42 inches worth of length when it sweeps. Then we have still one more issue that we need to resolve. And do you know what that issue is? Well, because this moves through an arc as it runs down, right, we've moved the pivot point down. The arc at this pivot point is different than the arc at this pivot point. It's higher up on the circle that it scribes, so it won't come all the way 42 inches back. It's going to be a little bit short. Well, do we know how much short it's going to be? Well, yeah, we can figure that out because it's a simple proportion. We know that at we have a 4-inch difference between the arc length, the 84 inches here, the hypotenuse length, and the length of the B side, right? There's a 4-inch difference, a little bit over 4-inch difference in that. And that's because at this point it's on an arc, and at this point it's linear because it's in line with its pivot point. So you're going to get the full 84 here, but you only have 80 when it's up because it travels the arc. We're going to have the same problem with the pivot point, but we moved the pivot point down 17.3 inches. So what's the difference between those two? Well, it's proportional, and we can calculate it, right? We can take that 4-inch difference right here between the 80 and the 84 and put it proportional to the 24.7-inch length and say we don't know, or X, what that is in the 17.3-inch case, but we can do the math, and we'll discover that it's a 2.8-inch difference. So what does that tell us? Well, that tells us if we leave the pivot point here and we let it swing all the way down, this is going to come up at an angle here to join it, and it's going to be 2 inches short of where we want it to end. So the way that we fix that is you could either lengthen these 2.8 inches, so when it swiveled down it closed, but that would change your geometry, right? Because it would push this point up higher and change your ramp style and try to force that down, which we don't want to do. But we can just move it out 2.8 inches. So when it swivels down, it'll go and it'll line up, because now we've moved the pivot point in the appropriate length, which is still 42 inches, 2.8 inches over to accommodate the arc difference that we have in that. All right, so that's how the math works out for here. Now, what we're going to do next is I'm going to go and I'm going to show you that we know that this is correct because we're going to use Bertha as a reference for that. But what we're going to also do is in the next segment for this is we're going to build a little mock-up made of wood. We're going to take these dimensions, we're going to put it on that. We won't put the hydraulics in. We'll be the manual portion for the hydraulics for that. And we'll try it and we'll see if everything more or less comes close. All right, so hang on for that. We're going to show you in a little bit how Bertha is implemented so that we know that we're on the right track. And then we're going to go ahead and we're going to build a mock-up for you, and we're going to show you that this math is correct. Once we have the mock-up and we're real comfortable with everything, we're going to go ahead and we're going to build the tilt mechanism. We're going to build the deck. We're going to build the lift arms. We're going to get the hydraulics and install them, and we're going to give it a shot and see what happens. All right? So I hope that that was informative. Stay tuned for the next segment here, and we'll give you a little proof of what we just went through. All right, so we have one more thing we need to discuss before we go down and we get confirmation by looking at Bertha on some of this stuff. Okay, so let's turn our attentions back to the math for a second, and I need to point something out to you. Remember that we're doing really special stuff here. We got the rollback, and we want to have a portion of the gate flip back up so that we can get access to the back and make this a custom tow vehicle as well. Here's our issue. This is 108 inches when it's in the deployed position, right? The way that the measurements work out is that I have 10 feet and 6 inches out to the edge of the frame rails that the deck would be over. So the flip portion would then be added on to the rest for 5 feet 5 inches. Okay, that's kind of an ominous number for us, right? Because 108 inches is 9 feet. We're a little over the 50% mark is where that's going to line up and put that hinge right in the middle, nearly in the middle of that ramp. Meaning that we're putting a design flaw in the ramp that'll want to collapse as you put weight on it. It's a maximum dynamic stress point on that ramp as you run things up is towards the center, right? I don't think that's going to work real well. I can't come up with a locking mechanism that I think can be stiff enough to support half the weight of a car or a truck twice, right? Because going up, hitting the first half of the car, and then going up and hitting the tail half of the car, and then when you come back down, you're going to get it again. That won't bend or cause an issue that would just make it impractical to do. So here's where we're at with that. We're not going to put the flip gate on it. We're not going to turn this into a custom tow vehicle. We're going to leave it as a rollback only so that we have a nice, strong design. But I still want a custom parts hauler and tow vehicle. So what that means is we got another project. We're going to go and we're going to get us another older vehicle, and we're going to make a custom tow vehicle, custom parts hauler out of it. And we're going to do some interesting things to that. But here's the question of the day with respect to that. Do we do a yin and a yang approach where we find another 64 C30 that's maybe a short bed dually and we convert that into it so that they're a matched pair, or do we do something different? For example, I know where there's an F600 that's somebody converted to a short bed, it would be about the size of Big Bertha, be a monster parts hauler and custom tow vehicle. What do we do? Or are there other approaches that we should take? So that's a question that they give it to me in your comments. What do you think we should do for the custom tow parts hauler? Match it to this, have a yin and yang set, or do something totally different and go crazy with it? Because I got some ideas for that too. Anyways, I'm going to leave you there. We're going to go ahead and go down and get our little confirmation that I wanted to point out to you off of Bertha. And we're then going to go and make our prototype slash right. Old guy forgetting. Anyways, we'll be right back. Okay, so we're on our way to Big Bertha here. Here she is. And remember, we modeled everything. We're going to duplicate what she has, just in a not quite so heavy stage here. So what I wanted to show you was, here is the bottom pivot point for Bertha. You'll notice that she's dropped below the frame rails, just like we predicted we need to. And I'm willing to bet you, if we go back and we look at the video when we were looking at the undercarriage of how to implement, you'll find that these are, when it's in a full up position, it's slightly tilted forward. At least that's what I remember it does. So here's confirmation that yes, we need to extend it, and yes, if we want it to shut all the way, we need to move it a little bit forward. So how do we verify that for true? Well, we're going to do a mock-up, which is what I couldn't think of when I was sitting at the desk talking about the flip gate, and design it up and see where we get with that. Okay, so that's what we're going to jump into next. We're going to jump into creating that mock-up, so stay tuned. You'll get to see that, and we'll see if it actually really works. All right, let's do a little bit more confirmation, okay? So we got the C30 out here, and we've got it set up. And I got some boards here as we get ready to go ahead and build the prototype or the mock-up for what we're doing here. And so here's the pivot point that we're doing. I pushed a rod through it. This is 108 inches from here to the tip of the board for that. So it goes down to the ground, and we're going to confirm two measurements here. Okay, first off, here's 108. So this is a angle measure. You can see right here that little red pointer line is set at 16 degrees. It's a little over, and actually it's probably minus 16 degrees, but you know what I'm talking about. So let's go ahead and set it down here and see that we're pointing right a little teeny bit over, which it should be just a teeny bit over because it's 16.404 degrees. So we got the angle right from our calculations. The other thing that we can confirm as we're doing this is, remember the distance, linear distance that it's going to stretch out when it goes and it does that is 8 feet 7 inches, which is right around 103. It's 103 inches. So let's go and look here, straight down from here. We should be hanging right over the edge of that tape. And if we go down here and we look, we'll see. Let me step on it so it won't move, and I'll pull it up a little bit. There we are, right at 103 inches or 8 feet 7 inches. So there's some more confirmation that the math works. All right, so we're pulling the rest of the materials together. We've marked a couple spots on the frame where we know things are gonna line up. We had to find out where the pivot point is on this frame, and then drop down for the leg extension when we go ahead and we do that. But what we're going to do is we're just going to basically use one frame rail. We're going to set the frame 16-foot frame rail up, hanging out just above this rail where we're using right here. We'll set it up. It'll come straight out and have the arms that'll come back down and connect right into here, and then we'll just go ahead and make it so it'll slide across, and as it slides it should lift and rotate it down and have it swoop like that. So we will, on our next stop when we come back, go ahead and show you the implementation of that and how it works. So hang in there, we'll be back. Okay, so we're back at it. We're out and we're getting set up to do our prototype, our mock-up, so that we can
check all our math, make sure everything's right. And you saw just a little bit earlier where preliminarily everything is falling out. So what we're going to do here basically is I'm going to make a pivot point right here where this big bolt is. Going to come up, going to set it at the height that this is going to be out, but we're going to move it out so we don't interfere with the rail, because if I put it over the rail, I'll have to trim the rail. You can see there's a little black line here. That's the 16-degree line that says that once we do it for real, we're going to have to trim it because it's going to want to come down the slope like that. But we've run into an issue, and I wasn't understanding why, and we're putting the drop mark in for the lift arms to come up and to connect here, and they're coming out in the wrong position. They want to be more forward, closer to that. So I'm scratching my head thinking about what the heck is going on here. And I figured, did I do something wrong with the math? Well, let's take a look, okay? So I got the math out here, I brought the math out, and I was rechecking my work on it. Let me tip you down a little bit so you can see it right here. And all the math is working out except when I get to this point. Remember where we made the proportional measurement here for this distance to this distance to figure out how far forward we needed to move it? Well, the math is right, but I made a wrong assumption. Here's what the wrong assumption is. It is proportional to the length, but I took a proportional to this length and then to this length, figuring it was the difference of it. It's not. It's proportional to this length and then proportional to the entire length. And it makes a difference because when I was laying this out over here, it wanted to be about just shy of 7 inches from where the pivot point is when it's straight up, like we've shown in the drawing, not 3 inches. And guess what the math works out if you do that? The old math was 2.8 inches. The new math, when you do it, is 6.8 inches. So voila. Don't let it ever be said that I don't make a mistake. The math is right. I just picked the wrong arm length that we needed to do because it's proportional. The arc difference is proportional to the entire swing, not the difference of the two swings. So we're going to go ahead. We're going to get this mocked out now that we knew that. Now it's making sense to me. We'll get this set up, and I got to build some I got to attach this here. I got to put control arms up there. I got to do the pivot point, and then we're going to do slides. And the way that we're going to do slides is I'm going to put a bolt hole here and a bolt hole here, and then I'm going to come down 42 inches, put a bolt hole here and a bolt hole here. We're going to draw lines, and we're going to make 2 slots. We're going to drill along the lines to fill them in, and then use my jigsaw to cut it out and make 2 slots. So that'll simulate the slide where we can push it forward 42 inches, simulating it going out. And then we'll have the pivot point here, which will then go down as it's being forced, and we'll have the when the armless, we're only going to do 1 rail because that's all we need to verify everything. Everything's then rigidly attached to everything across. So let me go and get some things set up, and we'll show you what we ended up with and what it looks like, and then we'll give it a shot and see what happens. So stay tuned. All right, we're back, and we got a mock-up. All right, so let's walk through it. So what I did is I cut a slit here. It's 42 inches long. That's going to simulate the slide for us, and it's on a pivot. This kind of bends when you, not bends, but it comes off of the slide. So probably didn't need to have to, but I wanted to emulate it as best I could. It is 16 feet long over there, and we have our lift arms right there attached in the spot where they needed to be, and we had that discussion of why we needed to move those. So I'm going to set you guys up on the tripod here. We'll take a couple measurements, and then we'll give it a try, and we'll see what happens with it. All right, let's point you down a little bit. There you go. Grab the tape measure. Okay, this is just supporting in the middle because it's not made of the material it should be. So that's all the way back. Let's go ahead and take a look at our center distance here, which is coming out at right about 44 inches. So it's supposed to be 42, but remember we're lengthened, so we have to run. We
got a 16-foot bed, so let's go ahead and apply some power to it. So we'll pull the slide down, starts to lift the bed. Keeps coming. We hit a stop. Oh yeah. Uh-oh. Design flaw. Got a bolt in the way. So let's move it out a little bit. We made it sloppy. Do that. And there we go. Okay, now this thing should pivot. Of course, we got another design flaw because bolt in the way. Make sure it's all the way down. Okay. Up a little, and we're almost there, but that could be the way that I attached. Take you off and we'll show you. This is out at the ramp angle, but I'm sure it's the way that I attached here to get the extra 4 feet. You know, this isn't exactly what we call precise. But it's a decent mock-up. We're fully extended. We're hitting the stop here for 42 inches. We've got this rolled forward. Let's take our angle finder, which is over here on top of the boat. See what we have for an angle. The red pointer is what we're looking for. That's right at about 16 degrees or so. Let's put it on the ramp. Yep, right on. See it right there, pointing right at the 16-degree mark. Okay, so we should have from that pivot point to here about 84 inches. We know that we have from here to here 66 inches. No, 108 inches. Sorry, I'm 108 inches out to the end because that's what it's been designed to do. Let's just grab the tape measure, put you back up on the tripod, move you a little closer. And see what we get for some measurements here. See if we're close. So our lift arms are a little long, but that's okay, it's working. We should have about 84 inches or so. Yep, right here. We're a little ahead of the pivot point. Pivot point's back here. It's well, you know, it would be to the end of the 42. This is supposed to go to the end of the pivot. But you know, we designed it to come to the end of the frame for where the pivot pivots. So yes, that is where it should be, about 84 inches, and that means we should have about 108. So that works out. Let's see, the base triangle should be, that's forward though, should be about 80. Yep, right about where it should be, about 80.5 inches from where the end is. It's lining up with that hole right there for the linear portion, so it's over that. So very cool. The math works. Now we'll go ahead and we'll reverse it. Remember, this is sloppy. It'll, when we implement it in its real form, will be a lot more precise. The pivot point's going to come right at the end. It's going to be on a rotating tube. The thing will really rock up forward, and we'll put it on slide so it doesn't get messy. So, all right, let's go ahead and power the sucker back up. I'm trying to power the sucker back up, but it's stuck because I got design flaws all over this thing. Because I got nuts in the way here. Might work it a little bit such that there we go.
right back down. And of course, if the pivot didn't rotate where it wasn't supposed to, it would stay up in the position it was supposed to. It'd be right there. Right back. Okay, but we wanted to verify our math. That was the intent. The general design works. You see that it lifts and then it comes down and slide. And you'd expect it because Big Bertha does that. So we're going to do that. But we're going to implement closer to Big Bertha using good bearing points, good points, very tight. This was just sloppily put together so that we can verify the math is correct. And the math is correct, but it did point out, remember, that we had to move that point forward in order for this to end where it is. I have it ending right where I want it to end, over here. Let's go ahead and rotate you. Actually, let's take you off. You can see, just trying to get it right about 2 inches from the back of that. Okay, so we're right dead on. You can see right there we're at 2 inches. So when it comes in and it comes down, it's going to do that. But we will take our time when we do the actual deck design and do the implementation. We're going to go step by step, making sure everything works, not throwing it together like this. But this proves very much that the math is correct and that our dimensions are right. We're going to have about a 16-degree angle. You saw what it looks like ramping up, so it's going to be a very shallow ramp to pull it up. This rotates to right in here, so when it comes up, we'll have the majority of the weight sitting over here. When it stops and it pulls it forward, we're going to have the most of the car weight or the vehicle weight that we have right over the rear axles. So I think we're going to be in good shape here. So that ends this portion of the program for this video. Let me know your comments. You see any errors, glaring errors, anything like that? You got any ideas for the final designs on how I should implement things? And we'll talk about that as we do the final design and we get it kicked into place here. So you guys will see that because we'll do a video. The beginning of the video will be talking about that. We might even do it and then give you guys a little bit of time to give comments back before we go and we do the implementation. But I got a pretty good idea of what we're going to do, how it's going to work. This won't be implemented with the rails on the outside of the frame. It'll be implemented with the rails on the inside of the frame, which will put the rails more or less probably 3/4 over the frame, which means we'll probably have to trim the ends here. You can see I got a little black line that indicates that 16 degree mark. We'll trim it, we'll box it, we'll cap the end of it so that when it comes in and it comes down, you don't have any issues, and we'll have hydraulic doing it. We'll make sure everything's square, make sure everything's flat. It's just got a lot of slop in it, you can see in here. I was really going to do 2 grooves for those bolts to ride in to emulate the slide. It was just easier to cut the thing out, but the bolts are spaced too much, so there's lots of slop in the slide that emulates that. So but it's done its purpose. It's given us the ability to mock it up and to take a quick look at to make sure that our math was right. So now I'm pretty confident in what we got to do and how it's going to work, and we'll get everything set up and designed the way it is. We're going to use big 1.5 to 2 inch pipes for all our rotating joints. Everything will ride on that. We'll use the next pipe up to slide over the top of those, and we'll have grease zerks, so everything will be a lot tighter and a lot neater. So just hang on tight there. And again, we appreciate you guys. If you do all that jazz for me, I would really appreciate it. And give me some comments, let me know what you think. All right, we'll catch you the next time. You guys have a great day. Okay, hi there. So I'm back for a little post-video pre-production update on the C30 in the mock-up and the checking for the correct answers from doing the math, okay? And I got 2 points that I need to make here. Let's look at the math again real quick here. So here's our math again page right here. Realize that this is a imaginary line that we're drawing in order to make our calculations and figure out where it is, right? We need to keep in mind that if you remember the mock-up, it had the kick up with respect to the pivot point. Well, the deck is going to be mounted about 5 inches above where the pivot point is, so we just need to keep that in mind. Now everything's parallel to the line, so there's not a big deal. It's all going to follow the same things, but we just have to accommodate the fact that when it goes to make contact with the ground, it's making contact of the ground with the bottom of the deck, not the top of the deck. So what we may want to do is put that 16-degree angle on the bottom of the deck so that the top of the deck will come down, and accommodate the fact that we're kicking up a little bit in our measurements, and that's really just around about the rotation. Realize it may rotate a little bit more, but all the numbers should be fundamentally the same because it's all parallel. The second point is, if you remember, I talked about how the lift arms were longer than what I expected them to be. Well, it makes perfect sense. If you stop for a second and you think about it, here's another drawing I did. This is the same as the one that we had previously, but here we have the deck fully retracted and in its flat position. We have our drop here, and then we have the lift arms coming up. Well, it draws another triangle, so we can thank Pythagoras again and use this formula to figure out what's going on here, right? Because this is the A leg, which is 17.3 inches. This is the B leg, which we know is 42 inches, right? So we can figure out what C is. C is the square root of A squared plus B squared. So if we put those numbers in and we do the math, it comes out to be 45.4 inches. Well, you know, we're getting right around 45 inches when we measure it. So again, it checks. It makes absolute sense because this is moving through the arc and it's coming up as the hypotenuse, not as one of the base legs on that. So those are just 2 points that we want to keep in mind when we do the real deck design. I just wanted to sum it up for you. So now I'll let you go. I appreciate it. Do all that jazz for me. And next time we come up with the C30, we're going to be working on the actual deck and trying to get things laid out. So we'll talk to you about that. Appreciate it, guys. Have a great day, and we'll catch up with you soon.